This is page 4 of the Unit 1 summative review. I'm going to jump right into solving the quadratic equations. There are multiple ways to solve these. I am only going to show one method for each problem. If you have any questions or concerns, you can feel free to email me, or you can try a problem a different way and just make sure that the answers match. So when I look at quadratic formula, the first thing I want to make sure is that it's equal to 0. Part A is. I am going to try to factor this. So let's see, x plus 3x minus 1, that's my factored form. I'm going to take each factor and set it equal to 0, and I'm going to solve. Now, one quick note, and let me finish solving these two. You can just box those answers up if you wanted to. You could write it down together. Just make sure you don't use parentheses around them because they are answers, not ordered pairs. One quick note, how did I know that these were the right values? Well, when I multiply 3 times -1, I get -3. When I take 3 plus -1, I get 2. The reason this works is because there's no number in front of x squared other than 1, and so we can use the real simple way to do factoring trinomials. I'm going to slide over to part B here. This one is not so straightforward because we do have a value in front of x squared, so you can either factor this with guess and check, you can factor with the AC method, you could absolutely throw the quadratic formula at it. I'm going to do guess and check. So I know 2 times 1 is 2. I know -1 here is going to be -1 times 1, and that's the only options I've got. So my guess is not that bad. I just have to figure out if the -1 goes here or here. So I'm going to guess it goes like this. And I'm going to take a quick check. So if I multiply the outside, I get 2x. If I multiply the inside, I get -1x. If I add those up, I get the 1x that I was looking for in the middle. Okay, so I know that those are the right factors. So I'm going to take a second. I'm actually going to delete what I just did because that's the check, not the answer. So this is all going to go. And now I want to take each one of these factors, just like I did in the first problem, set it equal to 0, and solve each. So I'm going to add 1. So I'm going to get 2x is equal to 1, divide by 2. So x is equal to 1/2. Please leave your answers as fractions. Thank you very much. And x is equal to -1. So again, you could absolutely just box those up separately. You can put them together, whatever you want to do as far as getting your answers together. All right, so that's part B. Let's talk about part C here. Part C, you can factor it. You could throw the quadratic formula at it. I'm going to do neither. I am going to recognize that x squared is the only variable in this entire problem. So I'm actually going to add 36 to both sides. I'm going to take the square root of both of those, and x is equal to plus or minus 6. Now, where did the plus or minus come from? If we think about something being squared to equal a positive 36, well, a positive 6 works. So positive times a positive is positive. But so does a negative. All right, a negative times a negative is still a positive value. So you want to make sure that you include both of those answers, so plus or minus. And I know when I put the square root in the problem, I immediately put the plus or minus in. The square root of 36 is 6, so there's my two answers. I'm going to slide over to part D here. Part D is not in a format that I like right now because it's equal to 7. So I'm going to subtract 7 from both sides. So x squared minus 6x minus 7 is equal to 0. Now it's in a format that I like, standard form. There's no number in front of x squared, so I'm just going to try and do the straightforward trinomial factoring here. So I'm trying to multiply to 7. Well, 7 and 1 is it. And I'm trying to add up to a -6. So -7 times 1 is -7. -7 plus 1 is -6. Take each factor, set it equal to 0, and solve. Let's see what you're getting here. So x is equal to 7, x is equal to -1. So again, you could just box those up as they're written. I just kind of condense it down for my own self. All right, 2 more to go for the equations. Part E, I've been doing problems like this for a long time, so immediately I recognize there's nothing that's going to multiply to 8 that will also add up to 3. It's just not going to happen. So if you can't factor it, which I can't, this one I absolutely have to throw the quadratic formula at it. So I'm going to label my A, B, and C values. A is 1 because there is a 1 here in front of x squared that we don't write, but it is there. B is 3, C is 8. Quadratic formula is up at the top corner of the page. I'm going to write it off to the side here. Opposite of B plus or minus the square root, B squared minus 4AC all over 2A. And I'm going to use this as a big substitution problem because that's what quadratic formula basically is. It's a big substitution problem. So anywhere I have the B values, I am going to replace them with 3s, and yes, I'm using the parentheses. Anywhere I have A values, I'm going to replace those with 1s, and the lonely C that I have gets replaced with an 8. Okay, so it's just a big substitution problem. Now, this big substitution problem is going to simplify in 3 ways. So the first thing I want to do is look at the -3 here. I don't need parentheses to just write down -3. All right, so plus or minus. The next thing I'm going to do is, using my handy-dandy calculator, I'm going to put everything under the square root in the calculator. So let's see what we get here. I've got 3 squared minus 4 times 1 times 8 is -23. I don't know what just happened there, so let's try that again. There we go. And separately, you're going to tell me what this denominator turns into. 2 times 1 is just 2. If you were to try to take the square root of -23 on your calculator probably will pop up an error message, possibly telling you it's unreal solutions or not real solutions. That's okay. So this is actually the answer we're going to use, and just leave it the way it is. Okay? All right, how about part F? Again, multiple ways to solve the problem. What you can't do, I'll be honest, right now as it's written, you cannot use the quadratic formula. I'm not going to use the quadratic formula to solve this. I'm going to solve by a square root because I recognize that this term right here is what's being squared, and there's no other variable in the problem. So I'm going to add 14 to both sides. So 2x plus 4 squared is equal to 16 plus 14 is 30. Divide both sides by 2. So x plus 4 squared is equal to 15. Now I'm going to take the square root of both sides, kind of like I did with that problem that was x squared minus 36. All right, take the square root of both sides. The difference with this one is I don't actually know what the square root of 15 is. If I put it in my calculator, it's going to come up with 3 point something. I'm not really interested in the decimal, so please don't use it. Leave it exact. And as weird as an answer is of root 15, that's exact mathematically. I'm going to subtract 4 from both sides. So x is equal to -4 plus or minus root 15. So wacky answer it might be, but that's what we're going to leave it as. And that actually represents 2 answers because you have both positive and the negative, so that's 2 different things. Okay? All right, so we've solved a bunch of quadratic equations. Now we're going to write some quadratic equations. So problem number 15, write a quadratic function of a parabola whose maximum point is 2, -4 and goes through 1, -1. Now, if you haven't thought about your key features for parabolas in a while, the maximum point or minimum point is your vertex. So the vertex for this problem is going to be 2, -4, and you have this other point of 1, -1. I'm going to zoom in on those because that's really the information I need. Now, your vertex represents h and k, and your point is x, y. And we're going to use those 4 values in the vertex form equation. So y is equal to a times x minus h squared plus k. So let's see, y gets replaced with -1. A we don't know, and that's what we have to solve for. X gets replaced with 1 minus h is 2 squared plus k. So you could either write plus -4 or just -4. Won't matter which. Now our job is to solve for a. So I'm going to add 4 to both sides. So that's going to be 3 is equal to a, and then in the parentheses, 1 minus 2 is -1. So let's go ahead and simplify that. -1 squared is just, well, 1. And then if I take a times 1, that's just a, right? Multiplying by 1 doesn't change anything. So now I'm going to use this a value that we just found and this vertex point to write the actual equation. I'm still going to use this vertex form that we have here, but instead of a, h, and k, I'm going to use the actual values that I know. You can either write y or f of x. I tend to do f of x when it refers to a function. So we've got an a value of 3 times x minus 2 squared, and then plus -4, or I'm just going to write it as -4 here. All right, so that is problem number 15 done. When you have a vertex and another point, use vertex form, solve for a, and then write the equation. All right, problem number 16, which I think is the last one on the page. Rocket is launched from a height of 2 meters. I'm annotating as I go. Reaches a maximum height of 50 meters at a horizontal distance of 20 meters. Determine the equation to model the path of the rocket. All right, so we need to draw a pretty picture to go along with this information. Let's see what we got here. So we have a horizontal distance. That's going to be our x-axis. And then we have height. Okay. Says a rocket is launched from a height of 2 meters. Let's go ahead and mark 2 meters here. And anything that's launched, kicked, thrown, any projectile like that, you actually follow a model that's a parabola. Okay? So it's that rocket gets launched, eventually come back to the ground, reaches a maximum height here of 50 at a horizontal distance of 20. So now I want to use these pieces of information and write some ordered pairs. So when the rocket is launched, its horizontal distance, it doesn't have any. It's at its launch position, but it is 2 meters off the ground. Its maximum height here is a horizontal distance of 20 meters with a maximum height of 50. So make sure you put those in the right order so you get your x-axis first and then your y-axis values. So we have a vertex here of, let's see, 20, 50, which would be our HK value. And we have this other point, in this case the launch point of 0, 2, and that's your XY. So we actually have the same information that we did in the last problem. I mean, obviously the numbers are different, but we have a vertex and a point. So we're going to use that same vertex form, y equals a times x minus h squared plus k, and replace what we know. All right, y is 2, x is 0, minus 20 squared plus 50. Okay, I want to solve for a. So I'm going to subtract 50 from both sides. So 2 minus 50 will be negative 48. Inside the parentheses, 0 minus 20 is negative 20. So let's see, negative 48 equals a times negative 20 squared is 400. Divide both sides by 400. So a is equal to, now that fraction is going to turn into some weird looking decimal that I'm really not interested in, but I would like the fractional answer of negative 3 over 25. Unless the directions say otherwise, don't use decimals, use fractions, they're exact, okay? So our last step here now is to actually write the equation to model the path. So our equation here is going to be f of x is equal to, our a value is negative 3 over 25 times x minus 20 squared plus 50. And that used our a value here that we found and our vertex point here were the two pieces we wanted to use. Okay? All right, so that takes us to the end of the study guide. I hope these videos have helped if you have been watching along and following along with the problems. Let me know if you have any questions or concerns.